class end?
In about 5 minutes.
In about 5, yeah, a little more minutes now, right? I better get to it. So of course, I will post this on Blackboard before the test, hopefully. Let me just go through it right quick here. So for the first one, we just need x not equal to -7, right? So the domain looks like that. For the second one, I get 42x to the 42. For the third one, multiply by x, I get 1 minus 2x over 1 plus 3x. For the fourth one, factoring makes the x plus 4 cancel out. So I just end up with 9x over 4. For the fifth one, again, factor and cancel like factors. You end up with 2x times x minus 4 over x minus 1. Of course, if you multiplied out the numerator, I'd still count it right. This one breaks up like so, and we get 1 over 5x squared over 3, and minus 6x to the fourth. This one, you cannot break up like the last one because the addition's in the denominator, but we can factor out a 2a from the denominator and cancel that against the 8a cubed to give us 4a squared, like that. If the thing in the denominator factors, I'm not aware of it. If it does, cool. I don't think it does. This one, basically the minus pulls out, cube root of 64 is 4, and the cube root of 9, x to the 9th is x to the 9 over 3, which is x cubed. Rationalizing this denominator works out pretty nice because the denominator works out to works out to 2. And so when we divide by 2, we end up with 12 minus 4 root 7.
What if you put
4
4 to the root 7 minus 12?
4 root 7 minus 12, I don't think would be correct because that would be minus what I have. So unless I made a mistake, which is possible.
Oh, well, I think that's what I remember putting, but you can look at mine later.
That's okay, yeah. Again, I'll post this so we can, you can look back over it. And I'll also post a blank copy of the quiz so you can try it again if you want, To put the complex number in Cartesian form, basically the same trick, multiply by 3 minus 4i over 3 minus 4i. And so you end up with a 25 in the denominator, and 100 over 25 is 4. So I ended up with 12 minus 16i. This one, I made a common denominator of 21, which gave me 4x over 21 is equal to 11, and then 11 times 21 happens to be 221. So I get x is equal to 221 over 4.
We get that right if we put that, but then for some reason I forgot to leave it like that. I just put it as a decimal after, but I got that number too.
Oh, you got the number, you put it as a decimal? Yeah, that's fine. It's fine, I wouldn't take off. Let's see here, this one, cross multiply, simplify, we get x equals to 3, which you can easily check, right? 3 plus 1 is 4, 3 plus 2 is 5, 4/5. This one, I add 2 to the other side, and then I square it, and that gives me 5x plus 19 equals to 9, which gives me 5x is equal to minus 10, which then gives me x equals to minus 2, and you can check that it works. And then finally, the last problem, isolate the root, square both sides, and then we get x squared minus 16x plus 64 equal to x minus 6, which then gives us this, which factors, and x equals to 7 is extraneous, and x equals to 10 is an honest to goodness solution. This was one of the problems we worked in class, but I changed it just a little bit at the start, right? But this was effectively one of the problems that was on the exercise sheet. So anyway, I hope that gives you a pretty good view of what the test is going to look like. It'll be very similar with different formulas. So good luck, everybody.